Hi, in this presentation, I'm going to illustrate researchers' effort in exploring students' learning datasets, starting by introducing the importance of such datasets, and then overview a briefing about the selected papers that utilized from that dataset. Afterward, exploring each paper critically, which were grouped thematically in one of these themes: students' activities as an individual, students' relationship and interaction, then course nature, concluding with my proposed work on this dataset. The dataset of interest, as what I would like to call it, is the student academic dataset. It is the one that's related to their educational progression, either the one that's extracted from the learning management system or exported from admission records, of course, including the pre-admission ones, or a merged set of both. The importance of this dataset is mainly characterized in enhancing the quality and the level of pedagogic process in a way that will be beneficial for students, instructors, administrators, and learning institutions and platforms. It's really important because it could help in improving and analyzing student performance by being able to predict their future learning performance and learning outcomes, and provide the needed assist at the earliest possible. It's also helpful for the management and the allocation of resources uh, and the syllabus and the courses and the enrollments. Uh, and also it's important for improving the learning style as needful by assessing and understanding student relationships and learning behaviors. So that's only some of the famous use cases that reflects the importance of such datasets. So the papers that were selected for this critical survey were mainly the ones that utilized from educational datasets to explore efforts in predicting student performance more accurately and at the earliest time possible. Or it is the ones that analyzed factors that could affect their learning outcome, as that will be closely related to my future research area of interest. Therefore, I combined the research papers into three themes based on three influential factors that might affect student performance, which are student activities as an individual, student relationship and interaction, and course nature. In the first theme, as you know, students themselves and their related activities are considered the best source of information and good indicators about student performance, where by analyzing their behavior or learning progression, their performance could be predicted as well, like if they will fail or be at risk of doing so, such that the needed help could be provided and offered in order to help them in program completion. That will not result in only helping the students, but also the program's administrators uh, who can guarantee their student retentions. They can have also a clue in how to improve the quality of learning environment and therefore improve their profits and reputation. Student grades, online course views or participations, pre-admission marks, quizzes, attendance are some examples of dataset attributes that researchers explored to analyze the behavior of the students under this theme. Um, Either if they were residence students, students who are available in a campus or in institutions, or those who are learning remotely, like the distance learner. However, such analysis was sought by different papers for different aims using various data analysis techniques, as what we will see shortly under these themes. Now, for the second theme, it is another, which is the relationship and interaction. It is another debatable influential factor, uh, which and I could say that it's the most debatable influential factors among those three, as student interaction and relationship with externals such as with lecturers or other students or teaching material and aids could affect their learning progression or learning performance. However, while some researchers proved the efficiency of such interactions, uh, others proved the opposite, and some other proved the insignificant, where there's no relation. And that we will see it in detail also in the related research papers. For the last theme, of course, the course characteristics or the nature of the course, it is among the major influencer uh, for the student performance, especially after the introducing of online courses and the transforming from face-to-face traditional classes to online self-learning mode or studies. Now, course grading scheme, level of difficulty, and many more other known and unknown factors were proven to be correlated with student achievements and their successful course completion, and that's what we will see it later for the papers related to this theme. So now in the first paper, researcher at Kyushu University, which is a Japanese university, were planning to help their teachers in predicting at-risk students at the earliest time possible. So they used a recurrent neural network algorithm to train a dataset, student datasets, that's extracted from their learning management system, which is called M2B. The dataset is consisted of these attributes, and these attributes were updated and recorded weekly until 15 week, the end of the course. So they used that algorithm with long short-term memory that can store long dated information in order to predict the final grade of the student performance. Now, in a recurrent neural network, it is an efficient algorithm to predict to be used in training time series data, as it has a built-in feedback loop structure allowing it to act as a forecasting engine. Now, as in a normal feed-forward neural network, it is unidirectional model where the input flow to the output in one direction. However, in recurrent neural network, the output layer at t equal n will be used as a feedback to another input layer where t is equal n plus 1. So they will predict the final grade every week by utilizing the previous week's output to predict the final grade. Like, for example, in week 2, they will get use of the prediction of the final grade of week 1 in the prediction of the final grade of that student. So they will use this algorithm, and beside that, they will use a multi-regression algorithm, and at the same time, they will measure the accuracy of the final grade prediction in every week. So as a result, they find that recurrent neural network is the efficient algorithm in the early time prediction for student final grade with an accuracy of 90% or above 90% in the 6th week. However, for the multi-regression, with the same accuracy, but it was very late, like in 10 week. So that concluded the research in proving the efficiency of RNN in early prediction of student performance. Moving to distance education learners and the impactors on their educational results and program completion knowledge gap. In this paper, the authors plan to investigate those learners' behavior to predict also at-risk students for early intervention. Now, 3 program logs of 248 students at Imabini Model Learning System at one of the Filipinas universities. These program logs plus the student admission records were extracted from that learning management system. And the authors planned first to decide among the extracted attributes the most valuable one using these algorithms. After that, they find out that those are the most top valuable attributes, and then they fed these attributes to these classification algorithms, and they measured the accuracy and the speed of those algorithms, and they ended up finding that the decision tree one was the most accurate one, and the number of the classified instances is more than others, correctly classified instances more than others, and the incorrect classified instance is less than others. However, the RIP tree was the fastest one, because they chose J48 for their prediction model. And they created the decision tree, and this was its accuracy rate. At the same time, they used the first top two attributes, the activity and the exam, in creating the prediction model, as they implied at the end that those two models can work more powerful together in predicting and evaluating student performance. Moving now to the next theme-related papers, and targeting now on-campus students. The researchers here aim to predict student performance by analyzing student interaction with instructors and other students, which is represented by their forum participation on Blackboard learning system. Similar to the last study, they wanted to predict student performance, which is the final grade, by selecting first the best indicators of student performance from the LMS and admission records of 60 undergraduate students where these records, where this datasets consist of demographic, BB forum participation, and academic grade records. Now, before that, they used a SMOT function in Weka tool for data pre-processing phase, where all attributes were merged from that different source of records, and it's been reformatted and transformed in order to remove any source of imbalance or biased information. So then 3 different classification algorithms has been used. This has been used to see which are the attributes that are repeated or selected, top selected attributes in these algorithm, as those attributes will be considered as the best attributes from their point of view. So after at the end of this process, they find out among 38 attributes, they found the GPA, test average, and those the rest of the attributes were the most selected one. And after that, they fed those attributes, and they measured its accuracy and different accuracy algorithm using also 10-fold cross-validation test, and they found that the naive Bayes algorithm was the most accurate one, and they used it to create the prediction model for the students' final grade. And that concluded their work. And at the end, the researcher implied that they're willing in predicting students who may fail, and stress to the importance of the role of the instructor in boosting the student performance by being more interactive with them and provide them the proper guidance. Also, they suggested marks allocation for forum participation, so students will be more interested in using it, thus boosting more their performance. And that's the end of their contribution. However, in this paper, the positive impact of interactivity was proved indirectly, as their main focus was to investigate if learning management systems have enough interactivity features that simplify learners' interactions and subsequently boosting their learning outcome. So to figure that out, they were aimed to answer the following research question. The first one was, what are the student opinions about the content management system? And the second was, how is their perceptions or answers to this? The first question associated with the student actual use of LMS system and their educational performance. So to answer these questions, they gathered the information using from two sources. The first source was the student themselves, and through questionnaires, they asked them questions related to these main categories and subcategories. After they answered, they grouped the answers into these categories, shown categories, and these are the kind of questions that has been asked. And the second source of information was the LMS records that consist of actual use records, which is the login, reading, and posting, number of posting, and logging and reading frequency and number of posting, and their scores in online discussion and exam and group project. So after the needed information were gathered, a modality analysis was conducted. A modality analysis, it's a sort of two-tier framework, multi-regression analysis, and it's conducted between questionnaire answers, which is a student's self-reported use of LMS, and they were acted as an independent variable, and the mediators, which is here in our situation is the actual use records, and the student performance that's acting as a dependent variable. Now the mediation analysis proposes that the independent variable influences the mediator variable, which in turn influences the dependent variable. Thus, the mediators can serve to clarify the nature of the relationship between the independent and dependent variable. To clarify, authors were aiming to investigate the indirect effect of independent variables on a dependent variable. As an output of the interview responses, at first, the most frequent used main interactive function was the learner interface, then learner content feature. However, the most used feature in all subcategories is the system announcement and learner interface and assignment handling and discussion board within the learner instructor learner block, which implied that learners were utilizing from a variety of interactive functions for learning purpose, and that's likely resulted from a well organization and leading for the course demands by instructor. Now, regarding their perceptions about the usefulness of the system interactive function, they found that learner interface categories were containing the most beneficial interactive functions of E3 system. However, the most function in all categories that were perceived as a major usefulness were also assignment handling function under the learner instructor learner category, and system announcement function in within learner interface block, and then assignment completion in learner self block, which reflect that their perception were originated from their educational objective. Like, for example, if their studying required that function, they consider it as a useful one. Now, moving to the results of LMS logs, the gathered LMS logs, they found that the login attempts was the highest, has the highest frequency, followed by the posting on the discussion board, number of posting, and then the reading frequency. Now, after the initial descriptive analysis of the questionnaires responses and extracted LMS logs, the core two-tier mediation analysis results proved generally that there is a positive impact of student self-reported of E3 system use and their actual use record on student online performance. And however, it was indirectly for some features of the first and directly for all attributes of the second. In summary, students' online discussion score was directly influenced by student self-reported login frequency and by self-reported frequency of using interactive learner instructor and learner interactive function, and all actual use record served as mediators between self-reported logging, and online discussion score. As it's clear here, where the arrow means that an independent variable has a positive, significant, and direct effect on a dependent variable. Additionally, number of postings was considered a mediator between self-reported frequency of using learner-instructor-learner-learner interactive function and online discussion scores. However, for the case of exam and group scores, the only change is that there is no direct significance impact between them and the learner-learner, learner-instructor. However, the rest of the relation in online discussion score were the same in exam and group scores. Now, which that result lead the authors to reflect on the importance of instructor role in designing of online material and related activities to maximize system logins and frequency of using learner-instructor interactive functions, which will lead in increasing their posting in discussion board, thus improving their overall performance. Moving to the next paper, where the authors here had a degree of uncertainty about how important students' online participation on students' grade. Here, researchers tried to explore that by analyzing and comparing extracted Blackboard record for learner interactions in online courses with student final grades using Bruscal-Wallis, or what they call it one-way analysis of variance test on ranks, which is ANOVA on ranks test. That extracted Blackboard logs consisted of students' access sets into different Blackboard functions. However, they were grouped into the following main attributes. For the online participation, it is consisted of the access heads to the group area and communication area. However, for the rest of the activity, it's related to their access heads to main content area in the Blackboard. So in this analysis, the mean of the overall students' online participation in different grade group, which were high, medium, low, and failed, were calculated. Therefore, the authors presumed that if online participation was an efficient educational aid, the mean of online participation heads would be for the students in the high grade group. Though the results were not very encouraging, as Blackboard online participation has no significant impact. Besides, when they analyze all the Blackboard heads in totals corresponding to the student final grade, they found that it was less important in distinguishing between high or medium grade group. However, that analysis show that less number of overall Blackboard hits are correlated with the students with lower grade. So that's concluded their work, and yes, it's a bit old study, but it's interesting since its results were cited widely, so it was worthy to be investigated. Next, it is another interesting research where the authors propose to investigate a debatable direct relationship between student interactivities. That's illustrated by the interactivity between student teacher and student himself, and a successful learning outcome, regardless, of course, of how the course is being taught. So they plan to explore that debate by answering these three questions. The first question is, would it be possible to implement a structure for the features of interaction data that is LMS independent for learning analytics? If the answer is positive, is there any relationship between student interaction and his academic outcome? And if yes, does the relationship depend on the interaction mode of the taking courses, like face-to-face or online courses? So to answer these questions, the authors analyzed two types of data sets for the two types of courses. In general, there were 8 courses that has been extracted. 2 of them were an online courses, and 6 of them were an LMS supported face-to-face course. So before that, when they search the literatures for the different categories that interactions can fill in, and they ended up with these three categories, and they ask the expert reviews to relate the 140 extracted interaction attributes to one of these categories. So, resulting in having more than 94% of LMS interaction fill under the three types of category. So by that, authors answered the first question and succeeded in improving the availability of more than one category for system-independent feature for learning interaction that can be utilizable in LMS data analysis. Then the attributes were tested using bivariate Pearson's correlation test and a backward stepwise multiple linear regression, where the last is it's a linear regression, but it will eliminate the insignificant variable values and exclude them. So it was applied between the extracted interaction attributes and the student final grade to find the most significant variable. So as a major outcome, as you can see here, the course 7 and 8 are the online courses and the rest are the face-to-face one. So they discovered that the LMS usage behavior in the two different courses mode were almost the same, as you can see. However, they found a significant relationship between various types of interaction and the student learning outcomes for online courses only. Besides, the author pointed to the importance of teacher existence and the content for active participation to excel the learning operations and results. However, students' interaction were less significant compared to student-teacher ones, but the researcher outweighed that to the way the course were designed. Another interesting paper. Now, as explored in the previous slides, in certain situations, researchers have pointed to the fact of the importance and the insignificance of student interaction between each other. But here, researchers plan to investigate when such interaction can be negatively correlated with student performance. So they hypothesized that less enrollment and huge communication between students from one hand and between the lecturers from the other were major aspects of completing the online courses successfully. So to figure it out, they extracted LMS dataset that contained students' time spent in learning management system, interactive elements in 349 online undergraduate courses, which is 2-year length course, from 6 institutes. And the main examined interaction features or independent variables or indicators were the time spent by the students and lecturers in homepage, gradebook, email, and discussion area. So those variables and students' outcome were analyzed using an algorithm that's called structural equation modeling, SEM, which require the conduction of multiple regressions simultaneously for significance measurement to establish relationship among variables. And besides, Pearson's correlation were used and RMSE-A test for measuring the key goodness of fit of the indicators were used as well to evaluate the strength of the independent variables. Now, for the main technique that they used, they followed these major steps. They created a theorized model at first, which is this one, to identify the relation between the latent variables and the variables that measure them. The latent is the variable that is unmeasurable. Then they created the path diagram for that model where and the goodness of fit was used to evaluate the discrepancy between theoretical constructs and its measurement. And then they evaluated the results and revised the model. So then, using the factor analysis and correlation analysis and the goodness of fit measures between indicators and constructs, they explore and analyzed this relationship, and the result was they find that the discussions had insignificant effect with their corresponding construct, which is the student faculty and faculty participation and student participation. And student participation was a significant factor for course completion. Also, they find that the higher student participation caused lower the program completion. Also, the high enrollment had significant effect with the faculty participation and student participation as its increased value lowered the lecturer participation and increased the student ones. Then, based on that fact, a revised model was created, the one that you are seeing now, and it is reanalyzed again, resulting in proving the significance of all indicators, which are the time spent in homepage, had the highest significance with student participation, and gradebook have the same with faculty participation. Last, student participation was in significance state with course completion. Therefore, course completion, faculty and student participation, and enrollment size correlated with each other as hypothesized. So the revised model was a valid illustration for the selected dataset. So as a result of so the author's implication about this result was mainly focused to course administrators, and as what they suggest, as what they reflect, they say that the importance of course completion as an indicator, they reflect on the importance of the course completion as an indicator to evaluate the success, and the time was the best indicator for interaction. And also, they say that lecturers need to manage their time spent in online participation as per the class size. Others evaluation criteria have to be considered by the course management, like hits, number of hits, access hits, and ease of access, and many more. Also, they imply that students should not interact for the sake of interaction, as it may lead to lower student performance, and as a major limitation, not all predictors were examined. And the limited provision sample of data that was not representative for all case scenarios that might be in online courses. So that's concluded the last paper in the second theme. Moving to the third theme. Now, in the first paper in this theme, researcher examined the effect of graded and non-graded courses on students' motivation for course completion, as they wanted to contribute in making guidelines for successful replacement of traditional classrooms with self-learning online short courses. The authors collected a dataset of 412 engineering students registered in two types of module courses, graded 1 and non-graded 1. All access hits for forum and participations and resources like file URL page added by teachers to students were among the exported dataset attributes. And to analyze them, K-mean clustering methodology with Euclidean distance were applied using multiple K values from 2 to 6, where Weka was the main used analysis tool. To summarize the conducted analysis, the authors calculated the sum of squared error for different K values, resulting in choosing K to be 5 numbers of clusters, which had a low SSV value. After deciding that and clustering the dataset, the main visualized output and its implication were in both kind of courses, researchers noticed that most of students' activities were done passively. And passively, that means they were viewing only the forums, as what you can see here. The most one is the forums, where those kind of viewers might not grasp the value of self-learning. However, less than 10% of students in both courses were those who were really an active learner. Also, forum views and resources were having the maximum number of hits in graded course in comparison to the non-graded one. And as interpreted by the authors, that students in general were studying to obtain grades and be certified. Moreover, the access hits in grading course was more compared to the non-grade one, which had been reverted to learners' preference in being taught by instructors than to be self-learned. So they concluded that the difference in learning modes had affected students' online access behavior. So to enhance learners' self-motivation, authors suggested that grades and certified courses continuous supports education and training would be required to improve student self-learning motivation. Moving to the second paper, and according to this paper, it had been arguable that courses and its difficulty could impact the accuracy of student performance prediction. The authors believed that their research would have a major contribution to learning community in understanding student behaviors in courses of varying difficulties and help them predicting their performance in advance for early interference. Now, these thoughts were stemmed after the introduction of a new grading scheme in India, which is called CBC EGS. And as per the new grading scheme, courses' final grade were calculated at 3 examinations before taking the major exam. So the researchers theorized that students could boost their performance, especially in difficult course, by predicting their performance in advance to early intervene. So to prove that, they applied different classification algorithm on the datasets of 1,000 undergraduate students for mathematics course and for analysis course. The mathematics course considers the difficult one, and the system analysis and design course considered the easy one. And they aimed to predict the final grades and major exam based on the first 3 examination marks. Now, they used different algorithm to predict the major exam and final course grade. So to predict the major exam, they used MLPN, ANN, and MLR, and SMO REG, and M5P to predict the major exam, and J48, decision tree, and RIP tree, and naive Bayes algorithm, and CART to predict the final course grade. Additionally, they evaluated the output model in each algorithm using multiple performance measurement methods like kappa statistics, mean absolute error, and others, using 10 cross validation tests and supplied test set. Now, the outcome indicated the significant relationship between students' major exam with course of varying difficulty, and M5P was proven to be the best in that prediction with an accuracy rate of 98, with a good accuracy rate compared to other. However, for predicting the final course grade, J45 and CART worked very well for for the easy course, but for the difficult course, no, it did not work. There's no significance. But the measurement of interest is the major course, and the M5P was successfully the one which can authors use or suggest to predict the major exam. So they can study, so teachers can use it to alert students to early study and boost their performance. Last paper. The authors here intended to identify mainly which courses can indicate a good and weak performance. So they aimed to be able to explain learners' progression during their years of study based on the discovered indicators, and to explore other related facts from their progression if possible. So they are doing that because they would like to share in the improvement of studying programs at their institute by providing learning community the needed knowledge and guidance to achieve that. And as a main guideline was the utilization of a pragmatic policy, like to make them to make teachers being able to predict low or high performance students using courses only for early intervention. Also, researchers wanted to prove if students' final grade could be predicted using course mark only, including the pre-admission courses as well. So, to achieve that, they tested different classification algorithms as shown to predict and analyzing student performance using high school course marks and their grades in the first and second year courses. Then among that tested algorithms, the most accurate model was the one that was considered. Courses that were of significant impact on student performance were identified from the chosen model. Last, clustering and visualization techniques were used to interpret students' performance progression and how indicators affected that, besides exploring other facts. So before illustrating the result, it's important to note that they also made a baseline to which they referred to evaluate the prediction model accuracy result. They made it by referring to the testing dataset for cohort 2, and they calculated the probability of grade C prediction, and it was 51.92%, which is calculated by dividing the number of students who obtained grade C, and they were 54, by the total number of student cohort 2, and they were 140. Now, after producing and testing the classification algorithms to predict student final grades, the evaluation results with an accuracy rate that is greater than a baseline is resulted, and therefore authors concluded that marks only could be used to build acceptable final grade prediction model. It's supposed to be that the chosen algorithm for prediction model will be used to find the courses that were considered as an indicators, like as what we see here, the naive Bayes, first nearest neighbor, and random forest with Gini index. But here, the significant variables or courses cannot be obtained easily. So authors choose decision tree for attribute selection, which produced roughly acceptable evaluation measurement rates. And as a resulting, and as a result, and resulting from the selection, only 5 courses were used to make the prediction model. To investigate students' progression, all their 4 years results were grouped based on their course final marks. And as initial result for first year, three clusters were found, as you can see: the low and intermediate and high marks. Same marks trends were repeated for both cohorts during their 4 years of study for most of the courses. Another observable fact: most of cohort 1 and 2 students found in the intermediate cluster in all years, except in the first year for cohort 2 and in second year for cohort 2 as well. To extract more information intuitively, authors represented the grade groups cluster, the mean of the cluster's grade that the students were belonging to during 4 years of study by 4 tuple. Then they were plotted in a hierarchical histogram chart, and among the main facts that were extracted from that views were the appearance of high and low marks group. That's mean only two groups. Also, most of the students sustained in the same group during their years of study, and most of those who begins with high grades ended with low ones, and vice versa. Now, another interesting visualization was conducted using heat map by sorting them according to clusters that they were belonging to. It was clearly visualized how first-year students' marks were improved toward the best. Now, the first year courses is until the last year is organized from left to right, and here they say that find out that first year student marks were improved toward the best, and the student behavior in the 5 selected these indicators were increasing or decreasing. So last interesting output, they found a new patterns where some courses had most of its students in high range or low ranges, like the courses which is called HS 205 and 201, like this one, or this course, for example, high one, and this is the newly discovered thing. So since from the visualization most of the students' distribution belong to either high or low group, the hypothesized pragmatic policy can be considered as a guideline to follow in the predicting of student future grade as suggested or as confirmed by the authors. In conclusion, as observed, students' records dataset can be a source of valuable information that can be of interest of students, lecturers, or any other learning community's members. Also, we saw a variety of analytical algorithms where there is no rule of thumb for a model that may work efficiently for all cases, as literature indicated that no single educational data mining model can work best for all situations or could provide equivalent prediction performance. But as we saw in the last explained paper, how clustering and visualization can be a vital source of interesting information without bearing the hassles of running algorithms to discover patterns or interpret stats results, and more faster in creation compared to other data mining analytical algorithms. So I decided, and differently from others, I am planning to use visualization and clustering technique to analyze a dataset that consists of variety of educational and admission records for students in order to find patterns or indicators that can help in the prediction of students' course grades represented by high, distinct, normal, and idle, which is for the low grades. Then those indicators will be used to create courses prediction model using most accurate classification algorithms. The results can contribute in defining at-risk students to alert them before their failure, thus assuring student retention, or knowing distinct students and utilize them in doing valuable things that may add returns to them and their institution or countries as well, like doing publishable work and or solving real problems in the world or for governments uh, and etc. So additionally, I would like it could be possible that other facts will be explored, like finding indicators for elective courses selection, as if identified, it will contribute in courses uh, resource management and instructor allocations for these kind of courses. RStudio, Microsoft Excel, SPSS, W are among the tools that may be explored to achieve the project objectives. And that concludes my presentation. Thank you for your listening, and this is the reference. And thanks again.